Hi, Algebra 1. So you're going to go ahead this week and you are going to be graphing parabolas. So this is super exciting because you're going to get an equation and you're going to be able to graph it. Now, the first one that I'm going to start off with is something that we actually call a parent function, but we'll get back to that in Algebra 2. But y equals x squared. Now, the reason that I like to start off with this one and that graphing this parabola is the fact of we can always, whenever we are graphing something, is use a table of values. So I'm going to go ahead and with this, I'm going to set up a table of values, meaning that I have my x values, whatever I'm plugging into my equation, and then I'm going to have a little bit of work, and then I'm going to have my y values. And this is going to then give me a coordinate point. Do a few more. So for right now, I'm going to start with plugging in -2. So I have -2 squared. That is equal to 4, meaning that this is going through the point -2, 4. -2. 1, 2, 3, 4, going through this point. Okay, then I'm going to do -1. So -1 squared is equal to 1, meaning that goes through the point -1, 1. We can graph this point. Okay, I have 0. 0 squared, that's an easy one. 0, this goes through the point 0, 0. 1 squared, 1, 1. 2 squared, 4 goes through the point 2, 4. You might start to see some patterns here. Now I'm going to do one more. I'm going to do 3. That's 9. Goes through the point 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, all the way up here at the top. Now, the reason I did that one is that you can start to see the shape of this parabola. And if you take your pencil and kind of make nice, smooth curves that go ahead and kind of connect these points. Remember, they're not lines, they're curves. You can see the shape of the parabola. Now, something that we learned about last week in terms of the parabola is that everything that's happening on this axis of symmetry, let's go ahead, this axis of symmetry here, so everything that happens on one side happens on the other. So this point over here also can happen on the other side, meaning that this would go through the point negative, I'm getting up at the top of my paper, that's why the headline keeps popping up. So that goes through the point -3, 9, and that's where we create this lovely parabola here. Now there's a few things that I want to go ahead and I want to point out. And the first thing is this relationship between, let me get down to kind of a lower amount here, this relationship between the vertex and your next points. So this is my vertex down here at the bottom. And I want you to notice that when, for your basic parabola, you go 1 to the right, 1 up. You also go 1 to the left and 1 up. Then the next relationship that I like you to use from your parabola, from your vertex, is that you go over 2, up 4. Over 2, up 4. Remember, these are always from your vertex. And if you'll notice, those relationships are things that are being squared. Last one here is from your vertex. You go over 3, up 9. Over 3, we do it in both directions, up 9. And then we use those relationships to graph our parabola. Okay, so the reason that I pointed out those relationships was because you are going to have vertexes at different spots. So, for example here, I'm going to scroll down, but don't forget those relationships, we'll come back to them, is that we are starting with the parabola y equals x squared minus 4x plus 3. Okay, I'm going to go ahead, I'm going to set up my axes over here. And we're going to walk through a few different things in terms of this parabola. So the first thing that I need to figure out from my parabola is my axis of symmetry. And if you remember, we kind of use AOS for our axis of symmetry. Now, when we have our axis of symmetry, we have a really cool way of figuring it out from standard form. And that is that we use the formula x equals negative b over 2a. Please make sure you have that information written down. Your axis of symmetry is x equals negative b over 2a. So I'll flip over to a light purple so that we solve this together. So for this axis of symmetry, we know that it's going to be negative 4 over 2 times 1. Okay, so that means 4 over 2, that equals to 2. So my axis of symmetry is down the line x equals 2. Now, for my vertex, I know my vertex is going to be on the line of axis of symmetry. So it's going to be 2 something. Now, as we found out from that first one, is that you need to plug in. So plug in AOS value into equation for your y value of axis of symmetry. I'm going to say that one more time. Sorry. Plug in your axis of symmetry into your equation for your y value of your vertex. I'll switch over to a little bit of a darker blue for us. So for us, it would be y equals, we're plugging in this 2 here, 2 squared minus 4 times 2 plus 3. That is going to be 4 minus 8 plus 3, which is going to be -1, meaning that our vertex is at the point 2, -1. So we can go ahead and we can plot this point here. Okay, so what we figured out from these values that we had up here is that there's a certain relationship between your vertex and your next points. So I want you to watch very clearly, and this only works when your a value is 1. I'm going to say that one more time. It only works when your a value is 1. So we're going to go to our right one, and then we're going to go up 1. And we're going to go ahead and we're going to plot this point. And then again, we're going to go to our left one, and we're going to go up 1. And then we're going to go ahead, we're going to plot this point. Okay, let's kind of remember those relationships that we had before. I think we went ahead, we used purple for that next one. So using purple again here, from our vertex, we're going to go over 2, up 4. Over 2, up 4. And if you'll notice, anything that happens on one side of the axis of symmetry is mirrored on the other side. Now, if we wanted to here, we could take our next step and go over 3. I'm not sure if it's going to fit on my axis here. Here we go. We can try it though. Over 3. Oops. Let's get a highlighter when we're doing that. Over 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. And we can go ahead and we can plot this point. Now I don't even need to do it on the other side because I know that if I follow this line around and anything that happens on one side of my axis of symmetry happens on the other. Okay, now we have this nice cool curve here. And we can go ahead and graph that parabola. There we go, we did it. Okay, so there's a few things that we need to point out about this parabola. We already know our vertex. So our vertex is at the point 2, -1. Oops, let's kind of make it a little bit bigger there. So our vertex is at the point 2, -1. It's this guy down here at the bottom. 2, -1. Okay, then we need to check on a few other things. We need to check on our y-intercept. So our y-intercept should be our constant. Hey, it is. That's totally cool. It goes through the point 0, 3. Okay, then I'm going to check on my roots. And my roots on this guy, my roots are the points 1, 0 and 3, 0. Now, when we're looking for our roots, we want to know when y is equal to 0 if it makes these two true. Okay, so I know that this can go ahead. I can factor this guy, meaning that I have x minus 3 and x minus 1. 0 is equal to x minus 3. 0 is equal to x minus 1. Remember all these things that we used to do. 1 is equal to x, so that checks off for this guy. Add 3. These are all coming together in terms of all the things that we've been doing this semester. That works for that guy. Okay, so far I've gone over my axis of symmetry, my vertex, my y-intercept, my roots. The only other thing that I would like to talk a little bit about is my domain. So my domain is from -infinity all the way to positive infinity. But my range, always remember your range is your y value, is going to go, it's going to start at -1 and it's going to go up. So y has to be greater than or equal to -1. Okay, so those are all of your basic notes. I have some more videos with examples for you.